today we're going to be talking about volume of rectangular prisms. Again, please remember all of our notes are leading up to our test on Friday. Today's notes, half of your test. Ask lots of questions. If we need to pause and talk about something further, please let me know. All right, so volume of rectangular prisms. Now, in the past, we've been talking a lot about area. Area is when I have a flat surface and I need to know how much space is inside that flat surface, right? So area is when we're talking about flat surfaces. So, for example, this is an example from a few upcoming weekends. All right, I've got a flower bed. Okay, I got to put some mulch in that flower bed. Now I need to know that area of the flower bed so that I don't buy like way too much mulch. All right, so that's going to be a flat surface because it's just a flat ground. That would be area. All right, if I had a pool, a swimming pool that I wanted to fill up with water, well, now we're talking about three-dimensional, right? Because a swimming pool is like a rectangular prism, usually. I know we got some weird shaped ones, so we're going to think traditional for right now of a rectangular prism. All right, so like these shapes would be some shapes of like a swimming pool. All right, now when I'm putting that water inside that three-dimensional shape, that's talking about volume. All right, so flat surface is area. Inside, the space inside of a three-dimensional shape is volume. Okay, so just because you're given a three-dimensional shape doesn't necessarily mean volume. Because, for example, on this three-dimensional shape, do y'all see that front triangle? That front rectangle? That's a flat shape, isn't it? Mm-hmm. Could I find the area of that flat shape? Yeah. The bottom rectangle, could I find the area of that bottom rectangle? Yeah. All right, guys, in fact, if I wanted to know the area of the outside of that three-dimensional shape, those would all be flat surfaces. That would be called the surface area, which we're going to talk about tomorrow. For right now, we're wanting to know about inside, so we're talking about the volume. So if we're filling something up, it's volume. If it's flat, it's area. All right? So I know I kind of reiterated, but it's really important. If it's flat, it's area. If we're filling it up, it's volume. Okay. So with volume, there are two different formulas we can use. There are two different formulas. Okay, I walked over here without a pen. All right, there are two different formulas. You'll see where it says symbols. You'll see where it says symbols. Those are our two different formulas. Now, one of them is more useful than the other. All right? One formula is more useful than the other. For the sake, for like 6th grade, which is where we're in 6th grade, right? Yes. We're almost out. All right, but we're still technically in 6th grade. So in 6th grade, guys, this is the formula that we use. All right, in 6th grade, this is our formula. All right, and that's great and that's wonderful because in 6th grade, the only prism that we have to work with is a triangular, I don't know why I'm focused on triangles today, is a rectangular prism because all of these are in the shape of rectangles. All right, if you look all over that sheet, that front sheet, everything's in the shape of a rectangle, isn't it? Those are rectangular prisms, okay? Now, the problem is when you get to the 7th grade and the 8th grade and the 9th grade and 10th grade and so on, guys, you're not just going to have rectangles, all right? That's when this formula becomes more important, all right? So I want to talk to y'all just for a second about the formula, all right? Do y'all agree that rectangle is the bottom? I'm gonna actually shade it in to make it even more obvious. All right, if you want to, you can do this on your notes too, because we're going to do it in our work. This is the part. Now, guys, you're gonna. I'm sure y'all have friends that have other math teachers. All right. I don't think the other math teachers are doing this at all. All right, and y'all know again, this is where I like to kind of go in and not overcomplicate, but give y'all some extra information. All right, y'all get some extra info. All right, so that shaded part is the bottom. Do y'all agree? Which means this piece up here must be the top. Do y'all agree with that? Okay, so there's my top. All right, and then what's connecting my top and my bottom? The H, which is the height. Okay, cool. All right, what letters are down here on the bottom? L and W. What LW? What does L and W stand for? Luke? Length and width. Okay. So we have our length and our width, and then we have our height, correct? All right, so now let's look at this other formula. Now this other formula looks kind of funky because it uses a capital B. Have I ever let y'all use a capital B before?
No.
No, in fact, before when we were doing area and we said base times height, if you used capital B, I was like, no, don't do it. No capital B's. It had to be lowercase. Because for us, that lowercase b was just like, how far is it down the side? So let's look, why are we using a capital B here? So if you look up here, it says you can also, which means this is our other formula, multiply the area of the base. So does big B just stand for base? No, big B stands for the area of the base. That's my big B, the area of the base. All right, and then we're going to multiply it times the height. Now guys, this formula you can use for triangular prisms. You can use, they're actually circle prisms, but they're called cylinders. It's where you have a circle like a Coke can. All right, think of a Coke can. All right, that's a cylinder because it's a circle on the bottom, it's connected circle on top. Okay, so that would be a cylinder. You can use this formula for that. You could use this formula if you had a pentagon that was stretched out to make a prism. All right, this formula is a lot more useful. All right, in the 6th grade, we don't have to use this formula. We can just use length times width times height because all of them are rectangles. But ultimately, is that really preparing you? Not so much. I don't feel like it's really making us ready. All right, so that's when I come in and I say, we're going to add a little bit more. All right, so guys, I want you to look again here. Do y'all see where they've labeled that as big B? They're saying that's the base. Not the base line, but the base shape. Okay, so let's shape that in just like we did before. I'm so sorry for the cough. So that's my base shape. All right, what shape is that base? What shape is that base? Ledger? Close. I can see why we would think that because it does look kind of slanted. Luke? Trapezoid. It's a rectangle. That's just a rectangle. Now, I know it's kind of like crooked, but that's because they're trying to show that three-dimensional shape. All right? So that is still a rectangle on the bottom. Can y'all see how that's actually just a rectangle? It's just sitting flat up, kind of. Okay. All right, so this is a rectangle. What is my formula to find the area? See, big B stood for area of the base. How would I find the area of that rectangle? What's a good formula? Braxton?
Base times height.
Base times height. And what's our other formula that we knew even before base times height? Anyone remember? Hand? Abfit? Length times width. So guys, do y'all agree that this rectangle, the area of this rectangle is length times width? So here's my question for you guys. If big B is length times width, that does say length times width times height. That's where this formula comes from. The formula we use, length times width times height, is because the base, the bottom shape here, is a rectangle. My base is a rectangle. And what is the formula for a rectangle? Length times width. So, for example, I'm going to kind of go over to the side. You don't have to draw this. I just want us to think for a moment. All right, guys, this right here, this is a triangular prism. Not a very pretty one. But that is a triangular prism. Are y'all okay with that? It's not very pretty. This is where it gets tricky. If I look at this, that's clearly sitting on this rectangle, isn't it? So it's tempting to say the bottom is a rectangle. But what shape actually gives this its full shape? What shape is this in?
Pyramid? Triangle?
This is the shape of a triangle, correct? We're going to talk about pyramids too in a little bit, okay? This is the shape of a triangle. So guys, what's happened here is those two triangles are the bases. Even though it's not on the bottom, because think about it, even when we did like parallelograms and we did trapezoids and we did triangles, was the base always the bottom? No. Same thing on these shapes. My base might not be the bottom. Like here, my base is the front and the back. That just means my prism has been tumped over, has fallen over. Okay? Here, this one's sitting on the base. That's fine. Is it always going to sit on the base? No. Guys, this is going to be really important that you're able to recognize the base because, again, are you always going to have these awesome rectangles? No, I say awesome rectangles because they're easy. Length times width times height. Done. Okay? Sometimes you're going to get to triangles. Sometimes you'll get to talk about cylinders. Okay, that's not the best cylinder, but there's a cylinder. This would be the base, and this would be the base. All right? Again, that's not on its base. Could I draw it on its base? Sure. There you go. Cylinder on its base. I guess that would actually have to be dotted, but whatever. Okay. There it is. Cylinder on its base. All right. But the whole point is, guys, is that your base might not be the bottom. The base just means that's the shape of your prism. Okay. Braxton mentioned a pyramid. I want to talk about that real quick. This is a prism because it's triangle to triangle. All right, we are going to talk about pyramids. We'll actually talk about them tomorrow. The way a pyramid works, and these are a lot harder to draw, actually, surprisingly. They don't seem like they'd be harder, but they are. A pyramid has to go to a point. Okay, so that's not a very good pyramid. Okay, but a pyramid goes to a point. Sorry, that's my very poor attempt at a pyramid. Okay, a pyramid goes to a point. A prism goes shape to shape. It's kind of like it's been stretched out into a tube. All right, like a tube, the shape of a rectangle. Or a tube, the shape of a triangle. I always think of that. Okay, so y'all know when you're like really little, they have those like little toddler toys where you have to stick the shape in the hole. That's what I think of when I think about prisms. Okay, because it's a long shape that you have to put in. All right, those aren't in the shape. They don't come to a point. Okay? All right. Are y'all ready to actually find some volume? We talked about shapes a lot. Again, volume is? Volume is length times width times height for these rectangular prisms, but volume is the space inside, and area is a flat surface. All right, here we go. All right, remember when we were talking about area, I emphasized, what do you always have to write? Formula. What do you always have to write? Formula, formula, formula. And you all get so mad at me for making you write the formula. Guess what you still got to write?
The formula.
The formula. And I don't care that it's the same formula in every shape. I need to see that we're using volume equals length times width times height. All right? So for this first example, I'm going to start off by writing, oh, it says find the volume, which means I've got to use my volume formula. And my volume formula says V equals length times width times height. So we write our formula. After you write your formula, do you just get to, poof, magically give me an answer? No. After you write the formula, now I need the numbers that you're using. All right, now this is where I'm giving my students extra work. I'm sorry. I love y'all. I love y'all. And because I love you, I want you to understand how that height works. Because next year in the 7th, 8th grade, if you don't get the height, it's going to be a problem when you get to this, okay? So, let's start by picking our length and our width. Can someone up here find my length and my width for me on A? What is a good length and width? Nick. 10 times 5. So I'm using 10 times 5 for my length and my width. Are y'all okay with that? All right. So obviously, what does that make my height? What does my height have to be? 2. All right. That's awesome. Now all you got to do is multiply those, but except for the fact that y'all's math teacher is super mean, so she makes you do more work. Okay. So what I want to see is if 10 and 5 is my length and my width, that means that had to come from my base. Because length and width, remember up here, length and width came from my base. So all I'm asking you to do, see where I had 10 and 5? See how it's 10 and 5 here? I want us to show 10 and 5 is this bottom rectangle. All right, what rectangle matches with that one? The top one. And now when someone looks at that, can they say what number is connecting those? 2, and 2 is my height. height. Okay? Sometimes they're not going to be the top and bottom, and I'm okay with that. I want to know that you're okay with your base not always being on the bottom. Okay, so guys, you can do that calculation in your head, 10 times 5 times 2, or you can use calculators again. What do we get when we do 10 times 5 times 2? Chloe? 100. All right, now guys, we still have to put a measurement there, so this is talking about feet. So now let's talk about feet. If I'm talking about the space inside of that, is that just a flat two-dimensional surface? No, now I'm inside of it. I'm talking about the three-dimensional shape, the whole thing, 3D. So what number do you think I'm going to put with that one, Kira?
3.
A 3. So the way you would read this would be 100 feet cubed. 100 feet cubed is how we would read that. Because, in fact, what's happening, if you look up in that top corner, what's happening is you're really splitting up that prism into all these cubic units, these little cubes. Okay? So that's why we call that 100 feet. Okay. B, we're still finding the volume. So what's the first thing I'm going to write down? Raise your hand. First thing we're going to write down, Allie Claire.
Formula.
And that is?
Length times width times height.
Make sure we have V equals. All right, length times width times height, that's fine, but you got to have V equals because is volume the only thing we talked about? No. And in fact, volume isn't going to be the only thing on that test. Tomorrow, if you look up at our calendar over there, our weekly work, it says we're going to do surface area. So we're going to have volume, and we're also going to talk about surface area. So you've got to show me that it's V, that it's volume that you're talking about. Okay, length and width. Raise your hand if you can give me a length and a width for this shape. A length and a width for this shape. What do you think a good length and width are? Remember, it doesn't have to be necessarily on the bottom. Length and width. What would be a good length and width? Someone new. Morgan, what do you think?
5.6 and 3.1.
Okay, we can do 5.6 because that is on the bottom. And then 3.1 would give me that measurement here. So that would give me the length and width of that bottom shape. That's an excellent way to always do the bottom and the top. Okay. In a lot of the other classes, that would work, Morgan. That's awesome. Okay. In a lot of the other classes, and I'm going to do this just so that we kind of have an example on our notes. A lot of the other classes, they said 5.6 and 4. All right, can we do 5.6 and 4 as my length and width? Yes. Let's see how that works. So let's do 5.6 times 4. Okay, now the problem is I need to know my height. And when you automatically look at this, it's tempting to put 4 as your height, but I've already used 4. So guys, I'm going to kind of, before I even put my height, I'm going to shade that in. We said 5.6 and 4, right? That's my length and my width, which means this is the shape, and this is that shading that I'm asking you to do. So I do want you shading this as I am. So that means this is actually my bottom. So my prism's been topped over. That's not a big deal. So if this is the bottom, where's the top? Just on the other side, right? Across from it. So if this is the right side, the top is the left side. Guys, now that I've shaded that, is that easier now to see where's the height? What's connecting my bottom and my top? 3.1. All right? I know it seems silly to do with these rectangular prisms, but do you see how that's going to be a huge deal when you get to have triangles and circles and all these other things that you're stretching out? So my height here is 3.1. Now guys, here's the good news. Y'all want the good news? I know what I'm asking you to do is a little bit more complicated. I'm giving you another step that the other classes might not be getting. All right? But here's the good news. If you multiplied 4 times 3.1 times 5.6, you'll get the same answer. If you multiplied 3.1 times 5.6 times 4, you'd get the same answer. Because does order matter in multiplication? No. So as long as you're multiplying those three numbers, we're going to get the right answer. I'm just wanting us to challenge our brain to be able to manipulate and turn that shape in our head some. Okay? All right. It's challenging those kind of visual skills, being able to manipulate that in your head. All right. What do I get when I multiply that? Braxton?
65.4.
69.44 meters cubed. Okay? Alright. The next one. We're still finding the volume. So what should I write down first? Liam? V equals length times width times height. Alright. Length times width. What's a good length and width for this shape? What's a good length and width? It's kind of easy to see where they're connected. Nick? Yeah, 1 1/3 and 1 1/3. That's the one most people have picked because we can see 1 1/3 and 1 1/3. Those go together, don't they? That looks like a good length and width to me. What shape does that make? That square. That makes that square right there in front. Do y'all agree? Okay. So there's my base. Is my base on the bottom? No. This one has been tumped over. So there's my bottom. Where's the top going to be? The other square in the back. So this base is in the front and my top has to be in the back. Are y'all seeing how it's tumped over? Okay. So where's the height? How do I tell how tall that is? The 6 3/4. Because that's what's connecting those two shapes. That's what's connecting those two. Right? Isn't that cooler than just being like, oh, I multiply the three numbers? All right? Now we're actually saying, I'm multiplying these because they're the bottom pieces. And that's the height because it's connecting them. All right? Y'all are getting a lot more out of this than just multiply the three numbers. All right? This is what's going to help you in the 7th and 8th grade, not multiply three numbers. Okay? All right, so now, guys, this is when use your calculator to multiply those three numbers. All right? This is when those calculators come in handy when we get that fraction work in. Real quick, I want to mention this. I noticed some people are going back. We haven't used the calculators in a while. Some people have had trouble with the fractions again. If you are not if you don't know exactly how to type those fractions in, please come and see me in the morning. All right, it'll take 5 minutes. We can do 3 or 4 examples together in 5 minutes, probably more than that. All right, and then you'll feel a lot more comfortable, and that's our goal here. All right, what do we get when we multiply those? Sophia?
18 yards cubed.
All right, try typing in one more time. I think we're a little off. I think we might have typed something twice. Braxton?
No, I was asking a question.
Yes.
When you to where 6 and 3/4 was the length, and then 1 1/3 could be the height.
Yeah, so we could have done like this back triangle and then the front triangle. Is that what you did?
Well, I was asking if you could do that.
Yeah, you can. Absolutely. Absolutely. And guys, honestly, it doesn't matter what order you multiply it in because technically I could have made the bottom the base by doing 1 1/3 and then that 6 3/4 would also be that bottom side measurement. So you can do any order. Nick?
12 yards.
12 yards cubed. All right. So guys, what I'm going to be looking for is I'm going to be looking, does your shading match the length and the width that you used? So I need to see the formula. I need to see the numbers so I can see if your shading matches, and then I need to see your answer. So formula, numbers, answer, just like before. The only thing we're adding in is the shading. Okay? Are there questions about those three? All right. Let's look at example 2. Am I finding volume? What does it say to find? Find the missing dimension. That doesn't say volume. That says missing dimension. All right. What a missing dimension means is a missing side or a missing number. All right. Ledger, what did you just say?
It already tells us the volume.
Ledger said it already tells us the volume. Where do you see volume up there, Ledger? Yeah, on top of the shape it says volume. There's your volume. Can't tell me to find volume if it's going to give me the volume. That'd be like the shortest math problem in history. Okay? Hey guys, guess what? Since we're talking about volume, what am I still going to need? The formula. So the first thing I'm still going to write down is the formula. So V equals length times width times height. Okay? All Alright guys, y'all know me. I like to make sure that equal sign, it can't move. The equal sign can't jump to the front. It can't jump to the back. It can't jump in between numbers. That equal sign has to stay where it is. So that's why I put that dotted line to make sure my equal sign does not move. Guys, you don't have to have the dotted line. If you're good at keeping that equal sign right there in the center, that's fine. If you know that sometimes your writing can get a little large or get a little funky, or if you're not the neatest person, please draw that line so we can make sure that we keep that equal sign where it goes. Okay. So all we're going to do right now, guys, is we're going to write what we know. So my first letter here is V. Do I know V? Yes, it tells me right here, V equals 1,485. So where V is, instead of writing the letter, I'm going to plug in that number. So underneath V, I'm going to write 1,485. And I'm going to keep my equal sign there. That's the whole point in that dotted line, to make sure it's staying separate. Okay? My next letter says L. My next letter says L. Does anyone know what a good measurement for L would be? What would be a good measurement for L? What do you think, Peyton? We can use 9. So underneath the L in the parentheses, I'm putting 9 because I'm putting a number, so I need to put parentheses around it so it stays separate. Okay, so I put 9 as my length. Okay, so the next letter is W. What would be a good number for W? This way? 15. If I use 9 as length, the only number left is 15. All right, why can't I use H as W? Like a totally different letter. That doesn't work. Okay. So we're going to use 15 as W. All right, and then we have H left. Is there a number for H? No, because we can see an H in the problem. So I'm just going to write H there. And since it's a letter, you'll notice I'm not putting parentheses around it. I'm not going to put parentheses around that letter, and that's okay. All right, have I done it, or is anyone lost? Have I done anything weird? Are we okay so far? All right, does anyone see anything that I can do, like anything that I can work out? Nick?
No.
Y'all see how 9 and 15 are next to each other? What operation is that? Multiplication. Can I multiply those? Yeah, so that's what we're going to start with, guys. We're going to go ahead and just multiply those two numbers. Okay, what do I get when I multiply those two numbers? Chloe? 135. So I get 135 there. Is anything else going to change? Nope. I still need the 1,485. I still need my equal sign. And I still need H. The only thing that changed is we put 135. If you want to put that in parentheses, you can. You don't have to. If we wanted to, though, we could. Okay. All right. This is called an equation. We had a test on equations. Then we solved inequalities just like equations. And now we're doing geometry, and we still see equations. Remember, our goal here is we want to know that missing dimension. We want to know what H is. Do I want to know what 135 times H is? No, I want to know what H is. So we've got to get it by itself by doing the opposite. Very good. So what operation is happening right now? Brian? Multiplication. I kind of gave that away. So Brian, what's the opposite of that? Division. And remember, guys, we're about to be 7th graders. Don't give me that dot division sign. All right, how am I going to write my division? Fraction bar. Thank you. That just looks so much cleaner. All right, what is it that I'm dividing by? So I did my division. If I do it to one side, I do it to both. So that's why I did it on both sides. What is it that I'm dividing by? What is it that I'm dividing by? Ethan? 135. Excellent. And if I do it on one side? On the other. And the reason he chose 135 is because that's what's next to H. I'm wanting to get rid of it. If that's what I get rid of, that's what I divide by. Okay. So over here, we got our calculator. We can type that in. What do we get, Ledger? 11. I'm going to leave that for right now. Keep my equal sign where that dotted line would come down. What happens to the 135 on top and the 135 on the bottom? What's going to happen to those two? Haley, what happens to those?
They go away and it just goes to 8.
Yeah, they go away. Those cancel, and it just goes to H. So all we have left there is H. All right, so I have 11 equals H. Well, that's great. But I don't know what that means. Is that 11 feet is my height? 11 miles is my height? 11 meters is my height? What has to go with that, Braxton?
The inches.
The inches. Now, here's the tricky part. Inches or inches cubed?
Inches.
Raise your hand if you can tell me, and give me a reason. Chloe? Inches. Why inches and not inches cubed? It's not the volume. Volume is cubed. Am I saying the volume is 11? No, just the height. That would be like me asking you, how tall are you? And you saying, I'm 5 foot cubed. No, that's not quite right, okay? So we don't measure height with a cube. That's just your inches or your feet or your miles, no cube. All right, so that's our answer. Done. All right, V, y'all think we can set that up? We're going to do it a little bit quicker. Let's write our formula. V equals length times width times height. Dot, 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 dot. All right. What do I know? What's the first thing that I know that I need to write down in that formula? Haley. The volume, which is 32.832 equals. The next thing is L. What is L? What is L going to be here? Braxton.
5.4.
Nope.
Oh.
What's it going to be?
What is it going to be?
What is L?
You don't know.
We don't know. It says L down here. Now, guys, I know, like, honestly, to me, it kind of looks almost like a B because it's got so much of a little curl on it. But that is their L. That is their cursive L on this worksheet. So we are going to leave that as L. So now, what is my width going to be? Anna Claire. 1.9 will work. And then what is my height going to be? Brian. 5.4. All right, what am I going to do first? What am I going to do first? Taylor. We're going to do that multiplication, 1.9 times 5.4. Now, guys, this is where I am going to get a little funky on you for a second. What do I get when I multiply that, Sophia?
10.26.
All right, and I'm going to put that 10.26 in the front. Because normally if I'm writing a number in a variable, it always comes number first, then the variable. So I'm going to put my L at the end. All right, that's like if you look in like a music list, like, you know, some music titles, like some titles of songs have like numbers in them, or even if you look at bands, some bands have numbers in them. Guys, if you look at them alphabetically, those numbers always come first, and then it starts with your letters. It's the same thing here. Numbers come first, then we have our letters. All right, here it didn't matter because we were just plugging it where the formula goes. But when we're writing our math out, we want the number in front. What did I almost forget to write down? I almost just completely left it off. The volume. We got to keep that there. All right, what's next? What do we need to do next? What's that, Nick? Divide. What am I dividing by? 10.26, because that's what's next to my letter. Guys, if you want, you can put that 10.6 in parentheses. You don't have to. If you put the L in front, that 10.6 would have to be in parentheses. It would be important, okay? All right, what do we get when I divide that? Chloe. 3.2? Centimeters, and that's equals to my length. She did not say centimeters cubed. She just said centimeters. Very well done. All right, guys, I want to talk to you briefly about the back on your homework. On your homework, it starts out by saying find the volume. Is there anything special about that? No. And guys, I know these are shaded in already. If you'll just darken a little bit what your length and width are, so I know your base and your bottom and your tops. Remember, bottom and top might not be the bottom of the shape. All right, so we're going to find the volume of the first 9. All right, then it says find the missing dimension. So that's these three problems right here, 10, 11, and 12. I put little stars next to those because those tend to be the more challenging ones because they have a little bit more steps. All right. Number 13 and 14, I'm going to zoom in a little bit on that. Wrong direction. Number 13, what does that say? Find the volume. Are you looking for a missing dimension there anymore? No, and look, it says the length, 9, the width, 4, the height, 5. You don't have to draw anything out. Just use your formula, write your numbers, find your answer. Same thing here. Find the volume. Write your formula, write your numbers, length, width, height, and then write your answer. Okay? All right, guys, we got about 9 more minutes. Let's get as much of this done as possible.